Good morning, welcome back. Now today in this session I am going to talk about building your own technology stake in the data science. So let us see what is the objective. Objective is technology keeps on changing, not only changing, it goes on improving day by day. So which technology we should use for data science, which technology will be good for project management, which technology will be good for a delivery of a project or a product. So technology choices have lasting consequences. A project technology stake determines the functionality and non-functionality. So we have two ways to address the issue. One is called a functionality, another is a non-functionality capability of our system. Okay. So this bidirectional link between the technology and requirement opens up an analytical approach for choosing the different technology for matching the requirement. So let us see what the technology stake is all about. So if you look at the topic, very simple, I have different technologies available, like I have Java, I have Python, I have full stack technology, I have so many variety of technologies which are available, database technology. So which technology should be used and which will be beneficial for our project development. So the topic include are defining the elements of the technology stake. Next point will be addressing to choosing between core and project specific technologies, and the third point and last is comparing the tools and products. So with this idea in the mind, let us see what a technology stake is all about. So on the right hand side you can see a figure where I have shown you something one at the top of the another, like our bread is a horizontal one. If you put the bread in the vertical form, it becomes a stake. At the bottom side you have filled cells, above than that application, above than that OS, middleware, and finally I have a database. It's just to give you a glimpse about what the technology stake is all about. May not be exactly corresponding, but this gives you a glimpse about over a one stake I have another and it goes as a stake operation. So a technological stake is a set of tools that your team uses to deliver product and finish project. So underline point is deliver a product and finish a project. When choosing technology, you start by defining their goal and thoroughly document all the requirement. From there on, your team and your people working with you will be going on. So what is the meaning of the technology stake? Very simple. Shaping a technology stake goes toe to toe with designing software architecture. Now software architecture is another field of our computer science and application, is a complete course by itself. So I will not be able to deal with more of the things about the software architecture, but it gives you which technology, which architecture will be very useful for a particular application. So the engineer on your team should start by drafting the system design that will meet everybody or everyone's requirement. Software architecture is a wide and deeply technical topic, so I will not, as I said, I will not be able to deal with more of the detail in this. Okay, so let us start. When I want to have a technological stake, point number one is collect the requirement and define the goals clearly. So we have seen in the earlier sessions how to define the requirement, how to define the goal. Next point is choose a set of architectural views for your project, and an architecture view contains visual as well as textual description of some of the aspect of the system. As most prominent example of architecture view are as follows. For example, infrastructure view. So what is the infrastructure I require? Represent the physical part of the system like server, storage system, storage arrays, network, and document, all these things. This is our infrastructure view. Component view represent the logical component of the software that you are going to build. Component view should define the isolated part of the system and interfaces that communicate with the outside world. Then finally, deployment view matches the logical representation of the component view with the physical reality of the infrastructure. So this deployment is going to combine the previous two, and the deployment view should describe how the system component will be delivered to the corresponding hardware. And the final other view, different methodology for designing the software architecture define other useful way. For example, there is another architecture called ArchitMate 2.1. Specification define different 18 architecture views that can be used for a different stakeholder. So for example, if you are defining for a insurance company or another company, you can define a architecture based upon your requirement. So, for the sake of brevity, we will cover only the main view that will affect the technology stack and omit the others. Define a list of necessary functions for technology that will be used for the development and operation of your system based on the requirement and the software design that have been produced by your team. Don't forget to include a very important concept about the technology is a cross cutting. That means one technology cut across many. So, cross cutting technology that will optimize the experimentation, development, delivery and operation of your system. So, underlying point is cross cutting. Cross cutting technology may not help you to find any specific functional requirement, but will be beneficial for our project in general. Experimental tracking framework, data version control system and continuous integration or continuous development are the services of the cross for cutting technologies. So, let us see an example. Let us build a technology stack for a customer churn prediction system. So, I want to make a system where customer will be retained or will be churned out or the customer will be loyal to you and things like that. So, I want to design a system called as customer churn prediction system. Our customer has defined the following list of requirement for the churn prediction module. We will omit the technical right now. Okay, let us see the point number 1. Point number 1 says that process the data from the marketing database, because this is a customer information. So, I have to worry about the marketing database. Let us say this contains customer information and the size of database is roughly about 5 GB of the hard disk space as a raw data. Agreed. Point number 2 tells me train the churn prediction model on a weekly basis, maybe on every Monday. And we should consider customers that have made no purchases for a month as to be churned out. So, a person who is not able, who is not purchased anything, naturally he can be churned out, okay, or he can be churned. Number 3, notify the team about the potential customer churn by using a remote API. This service should be available on the all the business days too, Monday to Saturday or Monday to Friday. Okay, so all our business day. Then, when I talk about the requirement, we go with the requirement in two ways. Number 1 is a functional requirement and another is a non-functional requirement. So, decomposition classify every requirement into two categories, functional FR and non-functional NFR. FRs include all the requirements that are related to the functions of the system that are core to the end user, and NRF include all the requirements that supply system that is applied to the system in general and define a set of constraints. So, non-functional requirement also play a very critical role when the system wants to be working. So, let us see how my team has decided, just as a hypothetical case, in order to understand the customer behavior and in order to understand the state. So, the team has decomposed customer requirement into following list. Functional requirement FR1, the system must be integrated with the customer marketing database. So, I already have a database in my system on a hard disk or maybe available on the database, and I have to integrate with the customer marketing database. FR2, the system must provide a customer churn prediction model, and we can consider customers that have made no purchases for a month as to be churned. FR3 tells me the system must call a remote API to notify the marketing department about a potential customer churn. And FR4, the model should be executed on Monday. So, you can see the functional requirement FR1, 2, 3, 4 tells me a very good glimpse about what is expected to be done. Next, let us see what NFR does it. So, non-functional requirement number 1, the system should handle processing of 5 GB database on every week basis. NFR2, the API should be available on the business days. So, let us see how this work in a total scenario, how this work. So, I have a raw customer data, I have a model training pipeline, I have a scheduler model prediction pipeline, customer churn alert, notify API and marketing department, and I have 3 servers: marketing database server, model server and CRM server, customer relationship management server. Now, let us see in detail one by one. If I talk about raw data is customer raw data represent the raw data that is used by the churn prediction system. So, here I have a raw data. Point number 2 tells me model training pipeline. So, model training pipeline represent a set of data processing and model training step group as a software component. Number 3, you can see here model prediction pipeline. Represent the component that is responsible for taking trained model to make the churn prediction and generate a customer churn alert. So, these 3 boxes, raw data, model prediction, and these are very important for the customer stake. Let us see the next point. Number 4 is scheduler. So, scheduler architects the work of other component by running pipeline based upon the schedule. So, I have a schedule every week, or on Monday I have to run it. So, I have a scheduler to do the job. Then I have customer churn alert here. So, 5 number is customer churn alert. We notify a notification event about the potential customer churn. Number 6 is here. Number 6 tells me marketing CRM system, customer relationship management system. So, this will give me customer information which are ready to be deployed on the system in the production. And number 7 is notification, API server that allows the creation notification about the customer inside the CRM system. So, now you can see that I have varied different components to be integrated together. So, I need a stake to be available. I have 3 servers: marketing database server, I have model server, and I have a CRM server. So, with this in mind, we can modify the we can integrate all the technologies put together as a stake. The advantage of using a stake is if one thing keeps on changing, or if I want to deploy something, I can go with the pipeline and can change the code and then easily can integrate them. So, the preceding software architecture diagram omit many technical, for the sake of clarity. The core idea of the following is not to deepen the knowledge about the vast area of the software architecture, but to give a general idea. So, let us see what we want. I am using Python as a programming language. So, is a debate, shall I use Python or shall I use any other language like our Java or another upcoming language like Julia or any other language like Go from the Google. So, let us say I am using Python. JIT for source version control, we have already seen day before yesterday, previous sessions. DVC, data version control, and JIT lab, for which CI/CD are there, and Jupyter notebook. So, if you look at this, to implement the functional requirement, I have FR1, I have a SQL Server database. For FR2, I will use SKI scikit-learn software as a machine learning library. For FR3, I use the API call which are available to store on the prediction data, and FR4, team has decided to use a CR on a popular Chronicle scheduler that can work on the command. Say CR on is a Chronicle popular very good scheduler on the Unix operating system. It will make the alert or prediction on a scheduled time. So, with this mind, to implement NFR, they decided to do the following. NFR1, perform load test and determine minimum necessary server configuration for model training. From the team perspective, we have a 8 CPU, 1 GB RAM and 15 GB hard disk, or maybe more. Should be sufficient, but we can go for more, so that the configuration is a baseline for my data set. And FR2 team decided to perform the API and maybe 10 times per day. So, with this idea in the mind, I want to choose between the core and project specific technology. So, a core technology and project specific, the difference is all of the team members will spend more time on a new language. Suppose my team decide a new language. So, let us see, technological choices should help the project prioritization out of the crucial step, and in which the team expertise and capability are also taken into account along with the constraint. For example, if our team consists entirely of the Python developer, choosing another language like Julia as a primary programming language may be a bad idea, even if the team sees that it is a further better out for the project. The problem, all of the team members will have to spend time learning a new language and practically destroying all the productivity gain using the technology. And number 2 is team conclusion may be over optimistic because of the lack of experience with the new technology. So, people have to get acquainted with the new technology. They have to the old technology has to go in the background and the new technology has to come in the forefront. So, these two risk abate if your team pursue a growth mindset, no doubt. Nevertheless, we should go for it, but it will take time and it will generate a lot of enthusiasm and new knowledge too. So, the core expertise in our team put a limit on what technology we should use in the project. Continuous internal research we have to keep on doing so that my project get enhanced too. So, this is the way, and we can view the internal technology research project using a Kanban methodology. We have already seen the Kanban methodology, and someone on the team spot the potential use of the technology, and experienced team members can do a quick review of this technology, and once the team manager decide, then we can go for our SMART criteria. The assignment of the two takes a single task for the backlog and finish as quickly as possible. And once the research has been done, the assigned report and the result can be formed a document or a talk that team can decide whether they will include a new technology or a core technology. So, with this discussion, it is very clear that what we want should be on a stake. So, if the decision is positive, it is crucial to create an educational program for internal technology adoption. The main result of this task is to prepare a workshop or a guide or an instruction booklet or some other educational material for the existing member and for the new members too. So, they will get familiarized with. So, you can see that core technology proves a very important role in the technological state. Process of adopting the new technology is as follows. Determine the requirement, see what requirement are satisfied by the core technology state, and if some requirement are violated by the core technologies, first search for the alternative, and some requirement may be used for the stake search of additional operation for the core technology uses. So, let us see an example. Let us say compare tools and product. So, it's always a debate. Shall I use Python or R language? Python is good for a data scientist, but R is very good for the statistical analysis. TensorFlow or PyTorch. So, this debate goes on X versus Y, that is I should use a best X for a particular Y. So, this debate will go on, and Google will give you or Google can give you a lot of material on the comparison of these two. So, let us see a small project case study. So, let us say we imagine we need to choose a time series forecasting or a time series forecasting framework for our project. Our team works primarily with the Python and has to provide the tool that forecasts all the time series data analysis. The main goal of the team is to forecast demand on a set of given product that shipped by the company. So, let us see what the requirement. I am showing you a table. The table has 4 columns: ID, that is identification, requirement definition, substantiation, score and priority. Now, look at the D1. D1 is your ease of the development. So, is the D1 tells me compatibility with the Python? Yet this is the required definition. Yes, Python is a major programming language for the team. Agreed. So, I give a score of the 3 because many of the people are acquainted and have a good command over the Python. So, I give a 3 number. As my way of testing or way of my substantiation or a score, and my priority is mandatory. D2 tells me compatibility with the sklearn, scikit-learn interfaces. Yes, the team has good experience on the using of the library function. So, I give a score of maybe 2 to 3, and this is also very important for the people. It is mandatory, and here it is important. Has good documentation. Yes. So, supplementary information is available. So, I have MIS. D4, forecasting can be done under 10 lines of the code, supplementary information. D5, can handle time space on a native database. Framework should be work on the raw data time series, and does not spend additional time on the data preparation. So, it is also important. Let us look at the forecasting algorithm requirement. Does not require manual hyperparameter tuning. So, it is a automatic parameter tuning on the model. So, since the library functions use the save large number of time series data, manual modeling is not be practical. So, it is a mandatory, and I give a score of 3. F2 gives me a function forecasting, provides several forecasting methods. So, availability of several forecasting methods, supplementary information, and works with the seasonal time series analysis or all time series like a weather forecasting or a what we call market trend analysis or a purchase and sales order analysis, or what we call as a any kind of time series analysis where the sale and purchasing of a particular share will depend on the time. F4 gives me provide confidence bound over the forecast. So, important. performance P1, P2 forecast time series and can handle the multiple time, and you can see that I have given 2, 2, 2 and they are important. Now with this idea in the mind, let us make the okay. So I have ID, I have requirement definition, substitution, score, priority. Now the team has prepared a list of the framework to prepare, like I am using PMD ARIMA, I am using state models.tsa, I am using Prophet, I am using LightGBM. So these are the framework which are used for my stake operation. So if I use this, then I have just now said D1, D2, D3, D4, F1, F2, F3, F4 and P1, P2 mandatory, important and supplementary. So I am using MIS. So I give the score 3, 3, whatever score I have given over there, I put them into a tabular form, and wherever the requirement is not necessary, I put a 0. So this kind of a tabular data will give me a very good comparison. So you can see here on the mandatory, I require this, I require this, I require this, I require this. So this is what we call as a data analysis. So this table can be further summarized to give the result of the following test. So if I add them together, I have 3 plus 3 plus 3 plus 3, I have total 12. So out of 12, how much is the score I am getting? So I can see that I am getting 10, 8, 10, or everywhere I can see the data as an analysis. So once I see this performance table, I will be in a better position perceptually and conceptually which technology should be used for. So this is how it works. Okay, so we can also use a weighted average if you want. We can use a weighted average also. For example, if I give more weightage to the PMD ARIMA, I can use a statistical model, or I can use another model, I can use a weighted average too. So this gives me a complete idea or picture about the different technological tools and stake available. So if you wish, you can use a weighted average to summarize each of the framework score into a single number. However, remember that simplifying complex decision into one number can lead to errors if not done manually or correctly. So with this, I end my session, and I hope that this gives you a better idea about which technology should be used, which is the metric to be used, and which are the functional technology, which are the functional requirement and non-functional requirement. Put them into a tabular form and then decide. This will give a better idea about the technology stake to be used in the data science project. Thank you.